Assignment number 2, immeasurable heights. There's a lot of things that are really tall and not measurable using conventional methods like a ruler or a measuring tape. Like, think of a surveyor who's trying to measure the height of a tree or a cliff, or maybe you're a student who's trying to measure the height of the school or a lamppost or a bridge. In all those situations, measurements are made indirectly with tools to find angles, distances, and the principles of trigonometry. Now let's look at this situation here. We have a person who's 1.5 meters tall. The person is 60 meters away from the tree, and they need to measure the height of the tree. Based on the information that we have, it's possible for us to find it because we know that if we're using trig ratios, the only thing that we need to have are 2 out of the 3 pieces of information. We have an angle and we have the 60 meters. This gives us enough information to find the height from here to here. I also know the height from here to the ground because that is the person's height. So if I took the person's height, add that to the distance that I've measured using trigonometry, then I have the entire height of the tree. So the height of the tree is our own height plus the height that was determined by trigonometry. Let's solve it. Now, this height we already know. Let's use this. We have the working angle here. We have 60 degrees, which is our adjacent. And here we have our opposite. So we're going to use tangent to find the opposite. Tan 24 is equal to opposite over adjacent. Let's cross multiply. So we have 60 times tan 24 is equal to opposite. 60 tan 24. And we have the value of the opposite as 26.7. Next, I'm going to add that to the person's height, 1.5. 26.7 plus 1.5 meters. And the total height of the tree is now 28.2 meters. So in assignment 2, you're going to be finding 2 immeasurable objects and using the measurements, in direct measurements, you're going to find the height of your tall object. Now, this is me during the pandemic. I wanted to find the height of this tree. I had a clinometer here, and I measured the angle. Next, I took steps, and I counted the number of steps it took for me to get to the base of the tree. That gives us 2 different pieces of information, and that's enough for us to find the height of our tall object. I'm passing out a data organizer in class, and there are a couple of things that you need to do before you go out to measure. You need to put your height in meters and your leg span. So now I know that I'm 150 centimeters, but in meters, I would have to divide by 100. So I could say that this is 1.5 meters. The leg span, my measured leg span was about 61 centimeters, but since I need to express that in meters, I'm going to divide by 100 again, and I have 0.61 meters. Right, so you need to think of two different objects that you would like, and when we go outside, you're going to take the measured angle and the number of leg spans it takes for you to get to the object, the base of the object. Okay, so different measuring tools. First is your height, feet flat on the ground. Find your height. This is a clinometer, and the clinometer will always measure the top of a right angle triangle. Okay, so how do you use a clinometer? You're here, and you're going to look through the straw. Up to the distant object. The string that's going down will give you the angle. Now, one thing about a right angle triangle. A right angle triangle has 90 degrees. That is going to be the largest angle there. All of the other angles are going to be smaller than 90. So even though in a protractor or a clinometer there are two different numbers, you have to use the one that is smaller than 90. Okay, so for example, if I'm measuring this, you see that this is between 30 and 40 degrees. So this is probably 36 degrees, and the angle up top here is going to be 36. If I wanted to find this angle, that's very possible. I have my 90-degree angle here, and this angle will be created by taking 180 minus 90 minus 36. Okay, so 180 minus 90 minus 36, and this gives us an angle of 54. Now, it doesn't matter which one we decide to use, but the reason this works is because we have similar triangles. So this is the height of the triangle. Here, we also have a 90-degree. The angle here is always the same. So this angle is similar to this angle, and the measured angle up here is the measured angle here. The last thing that you need to know how to measure before you go out to measure is getting your step length. This isn't a very exact method, but since we don't have meter sticks that are long enough to measure the distance from you to the object, we're going to use your foot length instead. So there are meter sticks in the classroom. You're going to start with your right foot at 0. You're going to take a step, and wherever your foot comes down, the distance between toe to toe is your step length. Okay, now you're ready to go outside to measure, and you're doing what was done here. Take your object, measure the angle, measure the number of steps that it takes to get to the base of the object. So be very careful that when you're doing this, you want to find something that's flat. Secondly, you're not going to be moving your feet until you are ready to count the number of steps it takes. After you have all of your measurements, you're going to use your trig ratios and everything you know about trigonometry to solve for the height of your tall object. You need to consider some of these reflection questions. When you're finished, you're going to present your findings in an interesting way. You could put it in a poster, you could put it in a report that's typed up, you could put it into a slide presentation, or any other way that's organized. Some people might choose to do a video, you could do it in a song, anything that is organized. To be handed in, you're going to take a photo of the data organizer and put that into Brightspace. Then you're going to also submit a final report with your results and your reflection. If you're doing it digitally, put it also into the Brightspace Dropbox. Otherwise, if you're doing a poster, please hand it in to me in class.